Welcome back. We're at lesson 9B and we are over halfway finished with our semester. So do a happy dance and then hit pause and go ahead and answer question 1 on your own. And even not only looking for the triangles, but also talking about similar sides and how we can set those up as proportions. So when you're looking at this drawing, the diagram, when it asks how many triangles do you see, here is a triangle. And why don't we go ahead and call it triangle AEF. That's one triangle. And then we have vertices on a larger triangle, triangle ABC. So to answer the question, we have 2 on the graphic. But I want to go ahead and look at some similar, because of the similar sides, I want to go ahead and look at some proportions and just touch on that before we head off through this lesson. When I'm looking at the small triangle, I'm going to say that I've got a left side, I've got a bottom, and I've got a hypotenuse. We're going to have the same parts in the large triangle. We're going to have a left side, we're going to have a bottom, and we're going to have a hypotenuse. And we're allowed to play around with these proportional sides. I'm going to keep it predictable and say that if we go with our small triangle, the left side, AE, we can write it as a ratio with the big triangle left side, AB. That's an A. I'm also going to say that if we look at the bottom of the little triangle, EF, we can write it as a ratio with the bottom of the big triangle, BC. And then finally, if we look at the hypotenuse of the little triangle, AF, we can write it as a ratio with the hypotenuse of the big triangle. Objectives for this lesson include that we will understand a geometric interpretation of interpolation. We'll be able to create a proportion between corresponding sides of similar triangles, and that's what we just looked at on question 1. We're going to use variables with subscripts, and we're going to use the formula for interpolation to find unknown values. 2 friends recently sold their vehicles. Both vehicles were Dodge Durangos. They were both in good condition, similar accessories, normal mileage. One is 2 years old and sold for $26,000. The other was 9 years old and sold for $8,350. I'm going to scroll down and let us look at the drawing that's going on here. And we've been talking about when we go to graph information, and then my brain loves to start this way just to see what's going on. And if we have time, remember we are putting time probably on the horizontal axes. So if one of these is at 2 years, and one of these is at 9 years, one's at 2, one's at 9, the one at 2 years was up here at $26,000, and the one at 9 years was down here at $8,350. So one here, and it looks like the value is going down. This lesson will examine the geometry, the picture behind the math, and introduce you to a formula of linear interpolation. And we're going to use the context of straight line depreciation. Here's the picture. They have year 2. They have just over 25,000, which will put us right about 26,000. And then out here at year 9, oops, hang on, there's 9. Oh, I did put 9. At year 9, we're down to about 8,000, which is this dot here. So that's where we're starting with our graph. This is a great time to hit pause and go ahead and look at least question 2 and maybe questions 2, 3, and 4. And then when you're finished with those, come back and we can walk through them together. Question 2 asks, what are the height and the base of the triangle shown above? The way we're about to look at these pieces of information is vital for this lesson. So don't leave question 2 until this really makes sense for you. If they want to know the height, I have to look at what's the highest point of our triangle and what's the lowest point of our triangle. One thing about the points that we looked at earlier is one point is at 2 years and $26,000. And let me go back to that page. The other point is down here at 9 years, and its value is $8,350. We have done several things with slope where we've looked at our x's and our y's, our x's and our y's. We've even labeled them accordingly. We're not calculating slope, but yet we are calculating parts of it. Because if this is asking for the height, it wants to know what's the difference in the y. And so the highest point is 26,000 and our lowest point is 8,350. And that's what we're going to subtract to find that our height is 17,650. And I'd love to go ahead and put dollars. Then it asks about the base. And very similarly, we need to find out what's the farthest left we are on our triangle and the farthest right that we are. And that's going to be our years, which would be the denominator of our slope. In other words, the change in x is going to be our base. In other words, from 9 minus the 2, that gets us 7. And I'd like to go ahead and call it years. If you haven't already hit pause and worked on question 3, go ahead and do so, and then come back and let's talk about it together. Question 3 says, let's apply the knowledge about similar triangles to the task of estimating prices for pre-owned Durangos. Part A asks us to draw the separate triangles and label the values that we know for sure for each one of those 3 triangles. Then using what we know about similar triangles, we're going to find the height of the top one. And the top triangle is this one. And we're going to find the height of the top triangle. And then part C says, what in the world does that value even represent? Or what in the world could it even be used for? So we're going to start by separating the triangles and labeling each of them for what we know for certain. And so we'll go over here and start with this top little one. And when we're looking at the top little one, we know some information like we know this is D sub 2 and we know this is D sub 5. We know that for sure. This over here is going to be a height. Let's call it Y sub 5 because we're dealing with this 5 over here. And then, let's see if we may know some more, but let's go ahead and go to another triangle. Let's go to this triangle here, the small one here. I'm looking at it. The top corner of it is D5. The bottom corner is D9. This one also has a height, and let's go ahead and be consistent and call it Y sub 9, like we did over here with the Y sub 5 for the D sub 5. Let's call it Y sub 9 for our D sub 9. We have one more triangle to label. I'm going to change colors. And that's the large one. So looking at our large triangle, I see D sub 2, D sub 9. Going back to what we had on our earlier questions, on question number 2, the height of this triangle we know is 17650, which is money. And we know the width of this triangle, which is 7. And if we know that this entire amount is 7, and this is 2, and this is 9, and the total distance is 7, but right here we're at 5, we also know that if from here to here is 9 minus 5, then we also know this bottom part or bottom side of the triangle is 4. And if this bottom part here is 4, then that bottom part there is 3. Using what you know about similar triangles, find the height of the top triangle. So they want us to find the height right here. And I need some more space. Let me erase a couple of things. When you go to use similar triangles, you need to find if they're, like we are going to be looking right now at this top triangle. We have something we know, which is the 3, the bottom, and we're looking for this height, which is what we don't know. And so we're going to be able to set up a proportion where we could say something like the height that we don't know, which is actually what we called y sub 5 a while ago, to 3. We then need to find something else that we do know, that we have this part and this part. In other words, we'll have the height of that triangle and we'll have the base of that triangle. And if we look at our very large triangle, we know its height and we know its base. So if we said height to base on the small one, then we would say height to base, bottom, on the other one. And once you have on a proportion 3 of the parts filled out, you are home free. You can start doing multiplication, and say y sub 5 times 7 equals 3 times 17,650. I can multiply those together, and then I'm going to divide off the 7, and what's remaining will be the height of my small triangle. So I'm grabbing a calculator. I'm going to hit clear a couple of times and then do 17,650 times 3 equals. And then I'm going to divide by 7 and say equals. And does it tell us where to round? It does not. Since it's talking about money on the height, I want us to go ahead and call this money. In other words, I'm getting $7,564.29 for the height of that side of the triangle. And I just answered part C. What does this value represent? Put another way, what could it be used for? And so it's a value. It is a value of just this piece of the triangle. We know the entire piece of the triangle. And if we are looking for, I've got too much written, but I want to write some more. Right here on D2, the price is 2, I'm going to go back to the other side. The price is $2,26,000 at year 2. We are looking for what is something going to cost at year 5. Well, year 5's price is right here. If I know the entire height of this triangle, and I now know this little sliver here, all I need to do is subtract. I'm going to take my price at $26,000 at year 2. I'm going to subtract this amount that we just found, $7,564.29, and I'm going to have the leftover height for the price of the vehicle at year 5. So I'm grabbing a calculator again. I'm starting with my clear, 26,000 minus $7,564.29. And the answer I get, and I'm putting these dollar signs on there, is $18,435.71. Part C does not ask us to do what I just did. It just asks, what does this value represent? And put another way is, what in the world could it be used for? And what it can be used for is to help us define the price at year 5. And this is how, and this is what it would be. Let's go ahead and see what we're supposed to be answering on 4 that we might have answered a little early. Now is the time for you to hit pause, go answer question 4, and then come back and we'll work on this information together. Looking at question 4, it says, recall the coordinate notation from the previous assignment, such as d sub 2 equals t sub 2 comma p sub 2. Use that coordinate notation to represent the work that we did in question 3. So I want to start right here, that if this is d5, d sub 5, it is located, since this is time and this is price, it's located at the t sub 5 and price for sub 5. Also, d sub 9. It's over here located at the time for 9 and the price for the 9th year. Part B, using this notation, represent how you found the base lengths of each triangle. Base lengths of each triangle. So let's start with the big triangle. And we have from here to here. So the base length of the tall triangle, and again, let me go ahead and do one here. I don't have d sub 2 on here. It's the time at year 2 and the price at year 2. And so if I'm looking to do the base of this top triangle, I need to know what's going on here and what's going on here, and I'm going to subtract. So this is the base of the top triangle. To find its distance, I took t sub 5 and I subtracted t sub 2. That's how I got the base. Let's do base of this bottom triangle. What is the base of this bottom triangle? Well, it's from the value at year 9. So the base of bottom triangle, I took the value at t sub 9 on the x-axis, the horizontal, and I subtracted the value at time of 5 years. And then finally, let's look at the base of the large triangle. And that's from here to here. So this entire base is the value from year 9 and subtract the value at year 2. Part C says, using this notation, represent the height of the large triangle. Height of the large triangle. The height of the large triangle is from here to here. And now we've shifted and we're looking over here at y values. And so noting that, we're going at the not the x values, but we're now looking at the y values. And so I need the one at year 2, and this is part C. Using this notation, represent the height of the large triangle. So the height of the large triangle, well, we start at the value of D2 on the y-axis. That's going to be P sub 2, and I'm going to subtract the value down here at year 9, which is the price at year 9. And then part D says, using all of this notation, represent how you found the height of the top triangle. Whew! So the height of the triangle, the top triangle, is y. It's what we didn't know and what we were looking for. And when we were looking for that value, we were able to set up height of the top triangle to height of the large triangle. Height of the large triangle looks like this. And then we said, so height of the small triangle to height of the large triangle. And then we said, what's the base of the small triangle? Base of the small, base of the small. This one. So base of the small triangle over the base of the large triangle, this. And this is probably a great time to hit pause and to think, to mull around, because it says, how would you find the height? Since this is the height, we're going to do the same thing that we did a while ago, but we're just going to leave it really abstract. So y times this T9 minus T2, it's going to equal the P2 minus P9 times T5 minus T2. And then like we did a while ago, we're going to divide off. Oh, wow, that went into gray. We're going to divide off this T minus 9, which is the base of the large triangle. And our final answer to find the height of that small triangle is, our y is going to be, and I know it looks crazy, P2 minus P9, which was P2 minus P9, which was this over here, the height of the large, times T5 minus T2, which this is right here, the base of the small, or the one at the top, however you've labeled it, over T9 minus T2, which is the base of the big one. Which this is a really good time to hit pause and go think back through this information to make that make sense, but we're not done. Because this just found the number for this height, but part E says, using this, the one we just found notation, then represent how we're going to find the price of D5. In other words, how are we then going to find this piece here? Well, remember what we did. We said, wow, if we've got all of this value for Y, which is just this piece here, we already know this piece here, so we subtracted the tall piece minus the small piece, and that got the piece right here that we needed. Tall piece minus this piece here is going to get what we need. I'm pretty much out of space, but I think if I change colors, I might can make it work. Okay, so we are wanting not the time at 5, but the price at 5. So that's ultimately what we said we are finding here. The price at 5 means I'm going to take the whole price at 2, this whole amount over here, not the time at year 2, but the price at year 2. And I'm going to subtract off all of this craziness over here that we just calculated. I'm just going to write it a little differently because we're headed towards something. I'm just going to pull this P2 minus P9 out to the front a little bit, and then put the other two pieces just behind it. This T5 minus T2, and I should be saying subs, and T sub 9 minus T sub 2. Now this is pretty intense. I would definitely hit pause, go back and look through this one again, but maybe you want to hear this next piece and then go back and relook at all of this. This is leading up to question 5. Your previous work, develops the general formula for linear interpolation using the coordinates of the 2 points. And in this case, it's going to be x sub a and y sub a, and x sub b and y sub b, and the x value of the intermediate, the middle point, to find the y value of the intermediate point. We get this formula, and I have pieces missing, and it's going to look like y equals y sub a minus y sub a minus y sub b times x minus x sub a over x sub b minus x sub a. Whew, lots of stuff. Question 5 says, let's repeat this process and go through all of this formula generating again. What I'd really like to do right now is, we played around with getting an answer earlier. I'd like to go ahead and play around with that, get our points written down, and go ahead and do some manipulation. To do that, I've got to erase a few things, and I'll see you back here in just a minute. So to put this in perspective, we've been talking about this triangle, actually a couple of triangles. And when we started the lesson, we were talking about what's going on at year 9 and what's going on at year 2. And then we were talking about, well, what could be going on at year 5, specifically, what is going to be this piece right here to tell us the price of the vehicle at year 5. This formula of interpolation needs several parts. It needs a point like what we're going to have at D2. It needs a point like what we'll have at D9. And then from this intermediate point, it needs to know the x, and then we're calculating the y, which that's what we're calculating here. So I'm going to go back to the very first part of this lesson, and it tells us at the beginning, here at year 2. At year 2, we have a price of at year 2, we have a price of $26,000. Let's go ahead and call this x sub a and y sub a. At year 9, we have a price of $8,350, and let's call it x sub b and y sub b. Later, it starts to ask us, so what's going to be the height at D5? In other words, we need the price at D5. So over here at D5, we already have the x, which actually is the time, which actually is 5, and we don't know the plain old y, this height. And that's what we want to know. If we know that, then we know at year 5, the price is going to be, and we can fill in the blank. So I'm going to follow this linear interpolation formula, put in what we know, and then we're going to grab a calculator and get after it. So the height y is, and here I go, y sub a. I'm just going to start finding my pieces and parts, which is 26,000 minus y sub a again, 26,000 minus, then it is y sub b. Here's y sub b, 8,350. And then I have x, which is 5, minus x sub a, which is 2, all over x sub b, which is 9, minus x sub a, which is 2. This is probably a really good place to hit pause and make sure you understand where all of these pieces and parts are coming from. To do the calculation, I'm going to rewrite my 26,000 because order of operations says if I have any parenthesis work, and I have some parentheses, I have some parentheses, and I have some parentheses, those need to be worked, and then we need to do some division and multiplication, which can happen pretty simultaneously. So I'm grabbing a calculator, but not really. 5 minus 2 is 3. 9 minus 2 is 7. I'm going to grab calculator and do $26,000 minus $8,350, and this amount in here is really $17,650. I'm going to hit clear a couple of times, and I'm going to start at the back end. I'm going to go ahead and say 3 divided by 7, and I'm going to hit equals. I'm going to keep going to the front, and I'm going to say times $17,650. I'm going to go ahead and round this, $7,564.29. And when I do the final calculation of $26,000 minus $7,564.29, I'm getting a value of $18,435.71. I've gone back to the slide for question 3, and I want to go back to where we were, that we used this proportion, we used some subtraction, and we came up with a value of $18,435.71. I'm going to go on back to the slide where we were and notice that we get $18,435.71. For this lesson, you're going to need to know one way or the other, using what we did on question 3 or using what we're doing back here on question 5, which is really kind of question 4. You're going to need to know how to use one of these ways to calculate the intermediate value of the price like of a car. This finishes lesson number 9B. You need to look at your syllabus to see if you have more lessons to work on. If you do, keep going. If you don't, make sure you're doing the homework, and I'll see you on the next lesson.